This video is about homework problems in Storrs Calculus book, 7th edition, in section 13.4, number 10 and 16. Let's do number 10 first. Okay, now they give us a position function. R of t equal to 2 cosine t. The second component is 3t. Third component 2 sine t. Okay, this is a position function. Okay, what do we mean by that? For example, 1t equal to 0. What do you have? Cosine 0 give you 1, so you got 2, 0, and t equal to 0, sine 0 is 0, so you got 0. Okay, this gives you the position in the 3D space. Okay, you give another t, I give another point in the 3D space. So you connect those points, you got a position function. Okay, they tell you where you are. Okay. Now we're asked to find velocity, acceleration, and speed. And velocity of a motion is derivative of position function. Okay. R is a vector function. The derivative of the vector function is take a derivative of each component, which is easy to find. So take a derivative of the first component, cosine t, give you negative 2 sine t. Then take a derivative of the second component, give you 3. The third one give you 2 cosine t. Okay. Let's give you velocity. Acceleration is derivative of a velocity. Okay. Therefore, you take a derivative of this vector function. So you take a derivative of each component. So the first one give you negative 2 cosine t. Second give you 0. The third one give you negative 2 sine t. Okay, so we find the velocity and acceleration. So next find speed. Okay. Speed is the magnitude of velocity, which is always positive. Okay. So that is magnitude of r prime t, okay, which equal to square roots. First component square give you 4 sine square t plus second component 3 square give you 9, then plus square of the third component give you 4 cosine square t. Okay, so that gives you 4 sine square t plus 4 cosine square t give you 4. So you got a 4 plus 9 give you square roots 13. That's give you the speed. Okay, now next let's look at the problem 16. In the 16 they give us a vector function. This time they didn't give us position function, they give us acceleration. Acceleration that has been given to us is like 2I plus 6tj, then plus 12t squared k. Okay. So first let's find the velocity. Okay, we know acceleration is velocity, derivative of velocity. Therefore, velocity, you take antiderivative, is integral of a dt. Okay. So that means we integrate each component. The first component, the plus, integrate the second component. That's j plus integrate third component 12 t squared dt, then k. Okay, integrate the first one, you got 2t plus c1, I, right, plus c. Since we have another c, we just make a differences, make a different notation. So the second, you integrate this one, you got 3t squared plus c2, j, just plus c, Integrate the third one, you got 4t to the third plus c3, For any choices of c1, c2, c3, you take a derivative, they will give you acceleration, But we're not looking for any. We're looking for the one such that, let me see, v0 equal to I and r0 equal to j minus k. v0 equal to I and r0 equal to j plus k. Okay. Now we find the velocity. Velocity for any c1, c2, c3. If you take a derivative, they will give you the a. But we're not looking for any of those. We're looking for the special one, such that v0 give you I. Okay, now the above equation, this v is a function of t. You let t equal to 0 in the above equation, then you will get your the first one, 2t, 2 times 0 give you 0, so you got a c1 I plus the second term, let t equal to 0, you got a c2 j, then plus the third equation, you let t, third term, you let t equal to 0, they give you c3 k. So the left hand side is I, that's in the right hand side is c1i plus c2j plus c3k. So that means your c1 must be 1 and the c2 equal to c3, they must be equal to 0. Then they make your left hand side equal to right hand side. Therefore, our v sub t here is equal to 2t plus 1 I plus 3t squared j, because c2 is 0, then plus 4t to the third plus 0, then k. So we find the velocity. This velocity, when t equals to 0, they will give you I. Now let's find position. We know the position function is the integral of velocity, because you take the derivative of your position function, give you velocity. So we've already find the velocity. Therefore, to integrate this vector function, we just need to integrate each component. This coefficient of I plus integrate 3t squared dt, that's coefficient of j, plus integrate 4t to the third dt, that's coefficient of k. Let's integrate the first one. We got t squared plus t, right? Integrate 1 give you t. then plus a constant. We give a name. We call C1 again, okay? This C1 is different than the C1 before. I plus integrate second one. Give you t to the third plus a constant. We'll give a name called C2. Okay. Again, this C2 will be different than the C2 above. Then plus integrate the third one, give you t to the fourth plus another constant we call C3. Okay, K. Okay, that is a position function. Okay. Now we're looking for a specific position function such that when t equals 0, they give us j minus k. I'm sorry. Okay. The problem is j minus k. So when t equals 0, my r there is j minus k. Okay. So let's look at the right hand side. Let t equals 0. The first term you got C1i, and the second term let t equals 0 you got C2j, and the plus t equals 0 give you C3k. Okay, you compare left hand side with the right hand side. So C1 this time must be 0 because there's no I on the left hand side. And C2 must be 1 because on the left hand side the coefficient of j is 1. And the C3 must be minus 1. Okay. Therefore, we find our position function as of t equal to t squared plus t and I plus t to the third, C2 is 1 plus 1, j plus t to the fourth plus C3, which is minus 1. Okay, then we're done.